Today's notes, we are starting with 2.4, composite and inverse functions. And in the warm-up, we're going to give you a piecewise graph and ask you to write a formula. Go ahead and do this with me. Whenever we write a piecewise, we give the name of the equation in front. So I'm giving this a g of x because it showed it labeled as a g of x on the graph. I make it equals, and I open some large brackets. Now I see there are three pieces to this, so I'm going to write the equation of each of the three pieces. The piece on the left is going to be generated by the linear function x plus 3. It has a slope going up 1 over 1, and you can plug in points to get that y-intercept. The horizontal part in the middle is going to be the equation y equals 1, because it goes through the y value of 1. And then the one to the right, starting at the x value of 2, is going up at a slightly flatter slope. It's a slope of 2/3. And if you calculate to find the y-intercept, you will also get a 2/3. This takes some work to generate these, but I know you guys can find linear functions. The other part of what you have to do is you have to set the restraints for the domain for these. So the left function starts at an x value of -5 and ends at an x value of -2. Notice the -5 is included, so I'm going to go ahead and underline that inequality symbol. The -2 is included, so you're going to either include it here or you're going to include it on the next restraint. It is your decision where to include it, but do not include it on both. I'll put it on the second one, but if you put it for the top one, that would be okay as well. Now, the last set goes from the x value of 2 to the x value of 5, and it does include both of those, and so you want to make sure you include both of those. What I would like you guys to do is put in the answers to question 2 and make sure to really pay attention to when you have an input, like on A, -4 is an input, and when you are given an output, like on 2B, that 3 is an output. Be careful, use the graph and the equation to help you determine the answers to A, B, C, and D, and then move on. Example 1, we are now going to go ahead and put some of this together and talk about compositions today. So example 1 says we have a gallon of paint. It covers 250 square feet. We write N as a function of A. We have already done this. We did this last week. We said N is a function of A. We find N by taking A and dividing 250. Pay attention to your input output. N is the output, A is the input. In part B, they now tell us that paint costs $30.50 per gallon. So we want a new equation, an equation C, where C is a function of N, the number of gallons, and we can find C by going 30.5 times N. In this case, N is the input and C is the output. What I can do is I can put two functions together and create a third question. That is called composite functions. Two functions may be connected by the fact that the output of one is the input of the other. And that is what we see in part C. They say now go ahead and write C as a function of the area A. So I am now going to write C as a function of A. I do this by starting with my function f of A. I do this by starting with my function C. C right now we have as a function of N. So right now we have C as a function of N. It is 30.5 times N. C is still my output, so I'm going to keep this C, but I do not want N to be the input. So I am going to replace the N. I take N, I find what it is equal to, and I replace that. And I say, oh, instead of N, I'm going to replace it with, I have my decimal in the wrong place. I am going to replace the N with the A over 250. Now I have written C in terms of A instead of in terms of N. Yes, you can simplify this, but for our purposes, I am just going to go ahead and leave it like this. At the top of the next page, we talk about looking at a problem with this. We talk about air temperature T in terms of chirp rate R. We have seen this problem as well already in a previous set of notes. Let's say now we get more information. Let's say we now find that the chirp rate R varies with time X. So now I have a new equation, and this is R in terms of X. What we want to do here is we want to write T as an equation with respect to X. So again, we are going to start with our original function for t. T is right now in terms of r. We are going to take the r. We don't want t in terms of r. We want it in terms of x. So we're going to take the r. We're going to plug in the r equation, and then we should end up with an equation in terms of x. Go ahead and simplify this all the way. Plug that r function in, 20 plus x squared, distribute the 1/4 in, and simplify. And go ahead and give me a final simplified answer on your Edpuzzle. Example 3, I will work you through one, and I'd like you to do one as well. I will do the first one here. F of g of 3, in case you don't remember this from Algebra 2. F of g of 3. We are not doing a contextual problem now. We are doing just a straight algebra. You start with the inside input, 3. So that is the x value. And you plug that into g. So we are going to start by finding g of 3. You plug 3 into your g of x function, and you get 3 squared minus 3, which should give you a 6. I can now replace my g of 3 with a 6 because g of 3 is 6, so I can sub that in. To find f of 6 now, I plug 6 into my f of x function, and I get 12 plus 1, which is 13. Go ahead and find the answer for g of f of 3 and enter that. Part B is very similar, but on this one, we are going to go ahead and find formulas. So we don't know the x is the difference. I will again go ahead and work out one of these for you. I will do the g of f of x one. G of f of x means g of, and let's input the f of x function. So my function f of x is 2x plus 1. We now want to do g of that whole expression. So we go to g. G says take your input and square it. So we input 2x plus 1 and square it, and then subtract 3. And I'm just going to go ahead and FOIL this out and simplify, and I should get an answer of, at the end, 4x squared plus 4x minus 2. You can pause to make sure you can get there. I am skipping some steps. I'd like you guys to go ahead and do this for the second one. Go ahead and do f of g of 3 and type in your final simplified answer. In addition to composition today, we also want to cover inverses. We'll cover this a couple times. So a couple things. The roles of an input-output can be reversed. So if I'm talking about population as my output based on t time, in this case, we have t is the input and p, population, is the output. But if we know population is increasing, and so that can maybe help us calculate the year, maybe we want to reverse this relationship. So I could write a new function where I have t as the output and p as the input. And so for this time, I'm reversing the roles here, and I'm calling p the input and t the output. The functions f and g, when we do this, when we reverse the relationships of the input-output, those are called inverses of each other. And a good vocab word here, a function which is said to be an inverse is said to be invertible. A function which has an inverse, we call it invertible. Some more information on the next page. Some notation here. If g is the inverse of f, we write it as f to the little -1. We do not ever say that. We always read it as f inverse. To express that the population of birds is a function of time, we say p is a function of t. If I reverse that and I want to be clear that it is an inverse relationship, if I want t to be output and p to be input, then I'm going to say t is a function of p, but because this is the inverse relationship, I'm going to say it is the inverse function of p. So if I know that I'm starting with one function and then I'm writing the inverse, I switch the variables and I can go from f to f inverse. That symbol f to the -1 is used to represent the function that gives an output t for an input p. So again, that switching of input-output is very, very important. Okay, let's take a look at a couple more problems here. On example 4, we're going to have p as a function of t. I would like you to type in, what does f of 4 represent? Think here what the input is. F of 4, 4 is the input t. Be really careful on part B. What does f inverse of 4 represent? If P is a function of T, then T is the inverse function of P. So when we do F inverse of 4, that 4 is now a population value. I would like you to go ahead and tell me what these represent. And remember, that means type in a statement. So go ahead and tell me what this represents as a statement. For example, 5, if we're working with an invertible function and we know on the function g, we have the point 10 comma negative 26. And on the function g inverse, we have the point 0.07. G inverse has the point 0.07. Then we know two other things. We know that xy points always get reversed for an inverse. So on a function, I have the point xy. On its inverse, I have the opposite point. I have the point y comma x. So if g has the point 10 negative 26, then we know that g inverse has the point negative 26 comma 10. So I can reverse this statement to get a new statement, a new g or g inverse statement. Go ahead and reverse the g inverse of 0 equals 7 statement and type that in. Example 6 says the cricket function, which we saw before, gives us t as an output as a function of r. What I would like you guys to do is go ahead and find a formula for r as a function of t. All you do here, we do not switch variables like we did in Algebra 2. All you do is you isolate the other variable. So if you have a function t equals 1/4 r plus 40, and you want to find the inverse function, I can't switch variables like we did in algebra because t and r have actual meaning. They don't just mean input output like x and y do. So if I want to find the inverse function, r equals, I just get r by itself. That is all. We subtract 40 on both sides. We multiply everything by 4. And then we're going to get our answer. Multiply everything by 4. And we will get r, which is the inverse function of t. And it's going to give us out 4t minus 160. Or you could leave that 4 factored out. Either way you write that would be just fine with me. Very last page here, we just have some notes about domain and range and inverses, and I want you to fill this in as well. Functions that have an inverse have a one-to-one correspondence between elements in their domain and elements in their range. So if a function is invertible, not only is it a function, but the inverse has to be a function. So everything has to match up. There can be no repeating elements from domain or range. The input values of the inverse are the output values of the original. So again, inputs and outputs get switched. Therefore, the domain of the inverse was the range of the function. So input output gets switched, xy points get reversed, domain and range get switched, etc.